guys. Welcome to the next part of power electronic lectures. Yes, we are in inverters. Already we saw in the previous session we have been solved so many problems which is which are related to inverters only. So there we understood how to utilize the that is how we are designing pulse width modulation controls. Just we saw some introduction, right? So let us start the let us start solving problems from there. As usual, while solving the problems, do remember whatever the instructions that I have given so far. So just keep smile and being active, conscious. And you have to solve problems. What can I say? Rumba speed up. Don't delay while solving the problems. Okay, and don't do mistakes also. To avoid the mistakes, you have to be conscious. Okay. Fine, sir. Now, in the last session also, we have been solved so many questions. I hope you all have remembered it. So let us continue from that. So let me bring the next question here. The question is a single phase. Once again, we are going to talk about a single phase. 1 minute. Yeah, a single phase full bridge inverter. That is the given. Controls the power in a resistive load. Okay, a single phase full bridge inverter controls the power in R load. Okay, sir. It is controlling the power in R load. That is the first statement. Now, what they told is the value of supply voltage, input voltage, as usual, they told it is 200 voltage. Under uniform pulse width modulation technique, we are applying uniform pulse width modulation with the 5 cycles with the 5 5 pulses per off cycle. It should not be, forgive me, 5 pulses per off cycle. They told 5 cycle pulses per off cycle. Okay, sir, this is given. Next, what they told is for the required control, the width of each pulse is. So what they told is the width of each pulse, the width of each pulse is given as 30 degree. The width of each pulse is given as 30 degree. Okay, sir. Now the question is if the supply voltage Vs increased by 20 percentage, if the supply voltage Vs is increased by 20 percentage, then the pulse width to maintain the same load power is dash. Then the pulse width to maintain the same power is dash. Now you can take your time and try to drop your answer in the comment section. Do it fast. First try to understand the question, then try to figure out the answer. Take your time, no issues. Yes. How many of you got the answer? If you got the answer, immediately drop it in the comment section because I'm just waiting for your answer. Answer. No one. Okay, you can also take few more minutes if you want. Any idea? No one? Fine. I think I have given sufficient time for this question. Let me try to solve it by myself. Listen, basically, what is this question? What they told, let us collect one by one. A single phase full bridge inverter, it controls the power in resistive load. They told that the output load is going to be purely resistive. First one. Conclusion, they only told that. And they told that supply voltage is 220. In between we have everything. So let me connect. So there is one full bridge inverter circuit inside with the pulse width modulation control, and input side we are giving our supply voltage. Okay sir, supply how much? It is given as 200 voltage, they told. Next, what they told is the pulse width of, see, let us continue. Uniform pulse width modulation technique is controlled under applied 5 pulses per half cycle. I hope you all know the meaning of this. See, we are considering one complete cycle means 360 degree. Half cycle means in 180 degree. In first 180 degree, we were received 5 pulses. That is the first conclusion. So between first 180 degree, totally we have 5 pulse width. Totally pulse width. Okay, sir. Next, what they told is the width of each pulses are going to be 30 degree. So this is one pulse. It width is 30 degree. Yes, sir. Next, if the supply voltage is increased further by 20%, already we have 200 voltage. Now they are further increasing it by 20%. Then the required pulse width, again we have to identify the new pulse width of individual pulse width of single pulse, right? That is the pulse width means they are asking what is the individual pulse width to maintain the same power. That is the question. Sir, how can I figure it out? Let us see. One pulse is carrying 30 degree. Then we know the total pulse width. They are simply talking about pulse width. I need total pulse width. We know the total pulse width is considered as 2D. That will be equal to pulse width of one pulse into number of pulses. Totally we have 1, 2, 3, 4, 5 pulses. If one pulse is having 30 degree, then the total pulse width in one half cycle will become 150 degree. First conclusion from this we can make. Okay sir, this is the case number 1. Under this situation, let us see. What they told is we have to maintain the same power across the resistor. This is our resistor. Let me conclude few more things here. The interesting factor is, I told you, no, whenever we are considering the resistor, I requested you all to, if you are calculating the output power, then it is mandatory to calculate the V0 RMS. RMS voltage square divided by resistor. Yes or no? We have to consider the output RMS voltage. Square times of output RMS voltage divided by R will give you the value of output power. Now what people told is, in case number 1, whatever the power that we are consuming in the output side, that is must be equal to the value of case number 2. In both cases, the power consumed by the resistor must be remain same. In order to maintain the same thing, what is the change is required in the pulse width? They have changed the value of input voltage. They are increasing this voltage further by 20%. So if we are increasing this voltage, automatically this output power will change. But what they are requesting as is, I need the same power in both cases. For that you can alternate this size of the pulse width. If you are altering the pulse width to maintain the same power in both cases at the output side, what can be the expected value of pulse width? We have to identify the pulse width now. Shall we continue? Yes. Case number 1. To know the output power in the case number 1, we know the formula, that is V naught RMS whole square divided by R. Okay, sir. And in the last class only I told you what is the formula to calculate the output RMS voltage when the moment we are using. See, they told that is single phase full bridge inverter and we are using pulse width modulation technique. So when we are using pulse width modulation technique in single phase full bridge inverter, the generalized formula to obtain the output RMS voltage is 2 times of D, that is pulse width, divided by overall time period. We are considering it for 180 degree. Out of 180 degree, the total pulse width with respect to the total time period, right? So we should keep these two people under root into we have to multiply it by the supply voltage. This is the generalized formula. We all know that. So in case number 1, I am considering it as V naught RMS 1 equal to, I am considering total pulse width is 2D1, case number 1, divided by pi whole power 1 by 2 into supply voltage Vs1. I hope we all know these things. Case number 1, we have found that the value of 2D1 equal to 150 degree. Why? How it is possible? For one pulse, they told 30 degree. Totally, we kept 5 pulses. So 5 times of 30 will give you 150 degree. That is the overall pulse width in the case number 1. And supply voltage is already clearly given in the question, that is 200 voltage. If I will substitute all those values, it will be coming up with so directly we can consider this value is what, 150 degree, and supply voltage is 200. So let me keep 150 divided by pi whole power 1 by 2 into supply voltage is going to be 200 voltage. This is V naught RMS 1. Treat this one as equation number 1. Okay, sir. Now what I am asking is case number 2. Case number 2 means what is the expected RMS voltage 2? In the case number 2, what we are going to do is supply voltage initially Vs1 is equal to 200 voltage. Now tell me what is the 20 percentage of 200? How will you calculate 20 percentage of 200? It will be equal to 20 into 200 in percentage. So I have to divide it by 100. That will be equal to 2 times of 20, that is giving you 40 voltage. Already we are having 200. Now further we are increasing 20% of 200 is 40. So the new resultant value is increased by 20%, means new resultant value will become 240 voltage. Already it is in 20. Sorry, already it is having 200. Now further we are increasing it by 20%. 20% of 200 is 40. Further it will be reaching 240 voltage. So supply voltage will become 240 now. So case number 2, the pulse width will be considered as 2D2 upon pi whole power 1 by 2 and the supply voltage is going to be 240. Actually in case number 2, we have to identify the pulse width only. So the value of 2D2 is not known. But anyone, can you guess what is the expected value for this RMS voltage V0 or 2? Let me tell you. The value of the resistor is fixed. I told you, see, P01 and P02 both are going to be same according to the given data. They told that they are maintaining the same power at the output side in both cases. So this can be further written as V0 square upon R equal to V0 square upon R. Case number 1, case number 2. R will get cancelled, square will get cancelled. Further I can say RMS voltage in case number 1 will be equal to RMS voltage in case number 2. That is indirectly what they are trying to mean. So I can say V0 RMS 1 in case number 1 and V0 RMS 2 in case number 2 both are going to be equal to each other. So we can simply equate them. So if I will equate equation number 1 with the equation number 2, the value of equation number 1 is what? They told this is 150 upon pi whole power 1 by 2 into 200. It will be equal to, again, in the right side, what will happen? Case number 2, pulse width is not known, divided by pi whole power 1 by 2, but the supply voltage will become 240. Yes, sir. Now further, how can we reduce this expression? What I'm going to do is, see, I'm writing this expression further. 1 minute, let me replace this data here. I need some space, so I'm removing these things. Okay, let us continue. In the next step, what I'm going to do is, I'm going to bring, see, let me write like this. We can write 150 whole power 1 by 2 upon pi whole power 1 by 2. This root can also be written in this way. 200. Bring this 240 to the left hand side. It will become 200 by 240 equal to, this can also be written as 2d2 whole power 1 by 2 upon pi whole power 1 by 2. Now pi whole power 1 by 2, pi whole power 1 by 2 will get cancelled out, and we can cancel this 2 0. Now we can cancel 5 times of 4 will be 20, 6 times of 4 will be 24. So further what we can do is 150 whole power 1 by 2 into 5 upon 6 equal to 2d2 whole power 1 by 2. Now I am going to cancel the square root on both sides. For that, I am squaring both sides. I am raising the square. Both sides I am going to square these terms such that this square root will get cancelled out and this square root will get cancelled out. This 5 will be squared. 5 square will become 25 and 6 square will become 36. All terms will be squared. So it will become 150 into 25 upon 36 equal to 2d2. That's all. Now what we have to do further? We have to reduce this expression. Now you can take your calci and try to figure out the answer for this. 1 minute, guys. Yeah. You can find your answer and drop it in the comment section now at least. So we know 150, if I will multiply 150 into 25, how many times it will become? 375, 3750, right? If you are dividing it by 36, so here what I am getting is 2 times of D equal to 104.166, 104.166. This is 2D2. Now let me explain. Actually in the question what they are asking, the question is initially pulse width of each pulse width they told that 30 degree. Now what is the same each pulse width? See what is the pulse width? Pulse width means individual pulse. For individual pulse, what is the pulse width? Again, we have to calculate. We know this 2D is what? Actually, 2D means it is the multiplication. Actually, what we did is I have taken totally 5 cycles, then I multiplied by 30 degree. Now I need the pulse width of one person. How can I do that? For that, let us further continue. So this 2D equal to 30 by 5 actually here. Now again, in order to know the answer, we have to divide this to know the individual pulse width. We got 2D2 equal to 104.166 degree. But I know this is for 5 pulses. This is for 5 pulses. 2D means pulse width, we know. This is the pulse width of 5 pulses. Then what is the pulse width of 1 pulse? Then to know the 1 pulse, you have to divide this value by 5 such that you will get the answer. So if I am dividing it by 5, what I will be getting? See, 2 times of 5 equal to, it will be 2 times of 5. That is 20 times of 5 will be 100. We can directly say. Then 4 will go there. 8 times. Then remainder will become 3 times 3 times 3 times. So that is the pulse width of individual pulse. Totally there are 5 pulses. 1, 2, 3, 4, 5. Now what is the pulse width of one person? It will be 20.833 degree. We got the answer. Yes sir, we got the answer. So how many of you got it? Gauri Muthu, good, 52, but there is some mistake I think. Just cross check. I am getting 20.833 degree. Okay, fine sir. Now let us go ahead with the next question. What is the second question now? The second question is going to be 1 minute. Once again, take the single phase full bridge inverter. Once again, we are going to consider single phase full bridge inverter uses displacement angle control. Uses displacement uses displacement angle control to vary the output voltage. To vary the output voltage. Here we are using displacement angle control to vary the output voltage. And here we have 1 pulse per off cycle. And here we have only 1 pulse. Earlier case we kept 4, 5. Now we have only 1 pulse per off cycle. That's what they mean. Okay, sir. Now the question is fundamental component of the output voltages. They told, just mark down this fundamental component. We know fundamental component means V01. So fundamental component of the output voltage is 60% of input supply voltage. Now the question is, then what is the displacement angle? What is the displacement angle? Everything is given. We have been solved so many questions already in the same model. Again, they have given the same model. Nothing is there to differentiate. Anybody can figure out the answer for this now? The question is pulse with this dash. See, are you guys are confusing with this displacement angle? Pulse width modulation only. Alternative name they have given. So pulse width, we are adjusting the pulse width, right? We are displacementing the angle. Just we are adjusting the angle. That is called the displacement angle control. So it is as usual pulse width modulation control only. Don't think too much. Just figure out the way to bring out the answer. What is the relation that they have given, sir? With the help of how can I figure out the answer? Just think about it and bring the answer. Given it is fundamental component, I have already given the trigonometric Fourier series expansion when we are discussing about pulse width modulation technique, and from that I told you how to get the maximum voltage, RMS voltage, everything we were already discussed. So it's time to explore the answer by yourself. I forgot to give the time. You can take further 2 more minutes. I'll be waiting for your answer. Do it fast. Slowly increase your brain ability. I'll be very happy whenever I'm seeing your answers in the comment section. So it doesn't matter whether you are getting wrong answer or right answer. All about the only thing is whether you people are continuously trying or not. So just put your answer in the comment section once you'll get the answer. It's pulse width modulation control only, I told you. It's a very simple question. Just think about it. So it's very important to observe the meaning of each and every technical words. Okay, fine. I hope you guys have tried. So let me try to figure out the answer for this question. Anyone? No? Sure. No issue. Let us try to figure out the answer for this question. Fine, sir. See, basically for this question, the question is a single phase full bridge inverter without displacement control. Okay, so that is pulse width modulation technique. Basically, there are two type of voltages. I told you either we can go up with the instantaneous voltage or general output RMS voltage. Like in the last case, we have been discussed about it, right? Vs into 2D by pi whole power 1 by 2. This is generalized output voltage expression. There is no any relation between this and fundamental voltage. You no need to be think about it here. They are talking about fundamental. They are not talking about this one. This is output voltage. I told you when we are having rectangle something, some waveform, normally how to calculate the RMS voltage, how to calculate the average voltage. That kind of formula it is. Then what is this fundamental? Fundamental should be derived from instantaneous voltage. V of t equal to summation. I hope you all remember this. What is the expected formula? I told you it will be 4Vs divided by n times of pi into sine n pi by 2 into sine n times of d into sine n times of n times of omega t minus n times of pi. This is the formula. Now from here, what is the maximum voltage? So generalized maximum voltage, we can say V naught nth order component maximum voltage. We can write this can be written as 4 Vs by n pi. This whole term, actually this whole term is going to be maximum into sine n times of pi by 2 into sine n times of d. Now output nth order RMS voltage. Nth order RMS voltage means we know Vmax should be divided by root 2 to obtain the nth order RMS. Now when we are dividing it by root 2, what will happen? So let me explain. When I am dividing it by root 2, you all know what will happen. N pi into root 2 such that it will be converted into RMS voltage form. Yes, sir. Okay, but during that conversion, we can rewrite this. See, this 4 can be written as 2 into 2. Further, 1, 2 can be written as root 2 into root 2. 1 root 2 will get cancelled here. So, this can be further written as 2 into root 2 times of Vs, that is supply voltage, divided by n times of pi into sine n pi by 2 into sine n times of d. What is this? This is output nth order RMS voltage. Internal harmonic RMS voltage. From this, if you want to know the fundamental output RMS voltage, then replace n by 1 such that when I am replacing n by 1, it will become 2 into root 2 Vs by pi sine. See, if I will replace n by 1, sine pi by 2 will become 1 into sine d, only sine d, n will become 1. This is the first conclusion. I hope you all understood this. Okay, sir. This is the relation between fundamental RMS output voltage, supply voltage, and pulse width D. Okay, sir. From this, we can easily explore the value of D, and then from the D, we can easily calculate the value of pulse width of each. Here, they clearly told that in one half cycle, it means in 180 degree, they are considering only one pulse width. So we don't need to do any multiplication or division. In our earlier case, they used to give pulse width of one pulse. Then we have to consider the total pulse width. For that, we have to multiply it by number of pulse width. So in this case, that things that are not required because here the number of pulse width is only one. So directly we can say what it is the 2D pulse width means the formula is 2D. Don't forget that. Here we are calculating only displacement angle. When we are multiplying by 2, then only we will get the pulse width. Okay, so this pulse width is nothing but the product of 2. Multiplication 2 should come with the displacement angle such that you will get the pulse width value angle. Okay, fine, sir. That is fine. Now, did they given any key to identify this? Yes. Given it is the fundamental V0 RMS voltage is 60% of the supply voltage. How will you write on that? So I can write output voltage equal to 60% of supply voltage Vs. This can be further written as 60 by 100 times of supply voltage Vs. Yes or no? 1 0 will get cancelled. 6 by 10 will be equal to 0.6 times of supply voltage. So we know, so this V01 can also be written as what? How will you write? 2 into root 2 times of supply voltage Vs by pi into sine times of D. Now here, this V01 can be replaced now by 0.6 times of Vs equal to 2 into root 2 into Vs by pi into sine D. Now this Vs will get cancelled out. Further, I can say the value of sine D equal to 0.6 into pi upon 2 into root 2. Now, if you reduce this, what you will be getting? 0.6 you have to multiply it by pi divided by 2 divided by, again you have to divide by root 2. So overall, I will be getting the value of sine D will be equal to 0.666. So from this I can say D is equal to sine inverse of 0.666. So if I will be taking sine inverse, so the value of D what I am getting is, it will be equal to 41.79 degree. But this is not the answer. Why? Pulse width will be equal to 2 times of D. Do remember that. That is very important. So 2D equal to, we have to multiply it by, if I will multiply it by 2 further, what it will be getting? It will become approximately 83.58 degree. This is the exact answer, not even approximate. So we found the value of pulse width. Remember one more thing. Suppose in the question it is given that the system is having 3 pulses per half cycle. In our question they have given only 1 pulse width. So actually we have to divide it by number of pulses such that we will be obtaining the pulse width of 1. In our case, in our question, they told that we are having only 1 pulse for 1 half cycle. Suppose if it is given that we are having 3 pulses, then what we have to do? To obtain the pulse width of 1 pulse, whatever the value that you people are obtaining here, that is for pulse width for 180 degree totally. In 1 half cycle, this is the total value. But this 83 is common for 3 cycle. Then what? 3 pulses. Then what is the pulse width of 1 pulse? To know that, suppose if 3 pulses are given, then you have to divide this answer by 3. So your answer is going to be 21.786 degree. Do you understand? For our question, this is the answer we completed because they told that only 1 pulse. So the width of the 1 pulse is 83.58 degree. In the last question, do you remember? I was dividing the answer by 5. Why? Because I figure out that the answer was the question is actually they have given 5 resultant answer for 5 pulse. To know the pulse width of individual pulse, I have to divide it by 5. So in your question, they have given 1, I have divided by 1. If it is given as 3, you have to divide it by 3. If it is given as 5, you have to divide it by 5. If it is given as 4, you have to divide it by 4. See, there is only 2 formula in PWM technique. One is this fundamental voltage expression, another one is this normal output voltage. See there, just by using these 2 formula in different way they are raising the question, right? Yes sir, they are doing. Chalo. Let us focus on the next question. 1 minute guys. Okay, fine. So now let us keep next question. The question, 1 minute. Let us change the question. The question is a PWM technique, a pulse width modulation switching scheme. A pulse width modulation switching scheme is used with a 3-phase inverter. Is used with the 3-phase inverter 2 dash. Why we are using this pulse width modulation switching scheme in case of 3-phase inverter? For that they have given further options. Option A, it will be minimize the it will minimize the load on DC side. Minimize the load value. Load value means that power consumed by the load value. It will be minimize the load value on DC side. DC side means where? Supply side. Second option what they told is it is increasing the battery lifetime. Battery lifetime. They told that. Now the third one is they are telling it is reducing the total harmonic distortion. Okay. Option D they are telling it is reducing the lower order harmonics. Sorry, lower order harmonics. LOH means lower order harmonics. It is reducing the lower order harmonics and increasing the higher order harmonics. What can be the expected answer? Anyone? What can be the expected answer? It may be option A or option B or option C. What is the expected correct answer? Anyone? Nobody? Fine. See, let me tell you. Basically, so far what we discussed, நம்ம இந்த pulse width modulation technique எதுக்கு யூஸ் பண்றோம் நான் ஸ்டார்டிங்ல சொல்லிட்டு இருக்கேன். Pulse width modulation யூஸ் பண்ணி நம்ம என்ன பண்ணுவோம் அப்படின்னா, I told you mainly our concern is third order harmonics, fifth order harmonics, some cases seventh order harmonics. So we are keeping our attention with the lower order harmonics. Yes or no? The major purpose. Pulse width modulation technique is generally used to eliminate the lower order harmonics only. Since the starting of the lecture I am telling. So when we are trying to reduce the effect of lower order harmonics, the higher order harmonics effect will goes off. That's all. But remember one more thing, sir. You are telling that it is reducing lower order harmonics, but it is increasing higher order harmonics, sir. Is it not the drawback for us? No, it is not. Why it is not the drawback? I'm just telling you. I'm just removing the effect of third order harmonics. Because of that, there is an increment in the higher order harmonics. It's okay. It's okay, it will not affect us. Why, sir? Why it will not affect us? I told you, no? Higher order harmonics means when you are keep on increasing the order of the harmonic. Suppose if I am talking about seventh order harmonic, I told you within 360 degree it has to complete 7 cycles. Just imagine about it. Its magnitude also getting suppressed, as well as its effect also will become insignificant. Again, if you will go 9th order, 11th order, 15th order, 13th order, when you are continuously increasing the number of order of the harmonic that much, suppose if I am taking 15th order, 51st order, because even harmonics will be eliminated. 51st harmonic means it has to complete 51 cycle like within 360 degree like this. See that it effect is almost insignificant, sir. It is negligible. Why should I bother about it, sir? So basically, when the moment we are introducing this switching scheme, that is pulse width modulation control in our power electronic circuits, especially in our inverter circuit, basically it is used to eliminate the lower order harmonics because they are creating severe effect in our waveforms. That's why we are trying to remove them, but at the same time it is also trying to increase higher order harmonics. But in resultant, practically we people experienced that these higher order harmonics are not creating any significant effect in our system. So because of the increment in this higher order harmonics, we no need to bother about it, so you can just skip it. Our major concern is lower order harmonics only. That's why though the switching scheme is increasing the higher order harmonics, we are not much bothering about it. We are keeping our attention only with the lower order harmonics, so we can happily what I can say, implement this switching scheme in case of three-phase inverter to eliminate the effect of the system. Okay, I hope you all understood this. Chalo, let us go ahead with the next question. Next question is, see, the load current. I am denoting IL. IL means load current. The load current of a three-phase full bridge inverter. Okay, we are considering three-phase full bridge inverter is continuous. Continuous means we know it meaning. Constant or we can take. It will be best word. Constant means ripple free. So it is constant ripple free. And what they told is they given that delay angle. Delay angle is given as delay angle is pi by 3. Okay, fine sir. Then what is the harmonic factor? The question is, what is the value of harmonic factor in percentage? They are asking the harmonic factor in percentage of a three-phase full bridge inverter. Option A, they told this is equal to 75.45 degree. Option B, they told that 62.34 degree. Option C, they are told that no, it is 27.65 degree. Option D, they are telling 31.08 percentage. Sorry, see, still my mind is going with the pulse width modulation technique. Harmonic factor, we should express it in percentage. Sorry guys, not in degree. Anyone? You can take 1 minute for this question. I won't give beyond this. What is the answer for this question? Just tell me, when we are considering a three phase full bridge inverter, what is the harmonic factor? What is the value of harmonic factor? Anyone? Anyone? Answer is what? Gauri Muthu Kunal Sarita. Okay, you people given the answer for the last question. Very good, very good. For this one, what is the answer? It is sufficient, yeah. Yeah, I have given sufficient time. What is the answer for? Sorry. What is the answer for this question? No one. Fine. See, it is fixed. You can go through your lecture. The value of harmonic factor. Harmonic factor means what? Total harmonic distortion. It is fixed. Total harmonic distortion is 31.08 for three-phase full bridge inverter. It is there in our lecture. Just do remember this value. It's a one more question only. See, they have directly given. To confuse you, they have given the displacement, difference between voltage and current, lagging, leading effect. They have given here. Not required. It is fixed already. It is independent of that value. It is 31.08 percentage. Just go through your lecture if you have any doubts about it. Okay. Chalo. So let us go ahead with the next question. The question is, as usual, we are going to consider a single phase full bridge inverter. Single phase full bridge inverter. A single phase full bridge inverter supplying resistive load RL. It is equal to 5 ohm. Given it is 5 ohm. And supply voltage Vs is clearly given as 60 volt. Okay, that is also given. Now what is the RMS output voltage at the fundamental frequency? Simply they are asking what is the output RMS voltage at a fundamental frequency. Fundamental means 50 Hz. At the fundamental frequency they are telling. Fundamental frequency. Answer please. Again you can take your time further. I will be giving 2 minutes. Start and drop your answer. Single phase full bridge inverter, load resistance given, supply voltage given. Output RMS voltage at the fundamental frequency is dash. What is the answer? I know where you people are stucking, but I am expecting it to be. There is no point of stucking. Everything is clearly defined. Do one thing. I need THD also in the same question. Total harmonic distortion also. Because here everything is data values are given, so it will be differ. You can calculate what is the value of total harmonic distortion factor, THD. If values are given, you have to go up with the formula. No one. Okay, guys, listen. What is the problem with you? என்ன கேட்டிருக்காங்க full bridge inverter தானே. Load resistance is 5 ohm. Supply voltage is clearly given. Output RMS voltage at fundamental frequency means they are talking about V01 RMS voltage. That's why they have clearly mentioned this point. Fundamental frequency means first frequency. N equal to 1. N equal to 1 means by default they are talking about fundamental RMS voltage only. How will you calculate this? Sir, we know for a single phase full bridge inverter, don't get confusion between pulse width modulation technique and a normal question. There is a difference. In pulse width modulation, we saw the questions, but this is normal question. Normally, for the simple single phase full bridge inverter, what is the V of t expression? Trigonometric Fourier series expansion can be written as 4 times of Vs divided by n pi into sine n omega t. That's all, it is over. Understood? So, whereas this is your maximum voltage. For the fundamental n equal to 1, then what will you getting? Fundamental maximum voltage. Let me talk about fundamental frequency maximum voltage is 4 Vs by pi, sir. Fundamental RMS voltage means I have to divide it by root 2, sir. So what will you be getting? 4 Vs by square root of 2 into pi. As usual, you all know this 4 can be written as 2 cross 2. Further, 1 2 can be replaced by root 2 into root 2. 1 root 2 will get cancelled with the denominator. This expression can be written as 2 into root 2 times of Vs by pi. That's all. What is wrong with you? Everything is given 2 into root 2 by pi into supply voltage is given as 60. 60 times of 2 will be 120. So 120, what you have to do? Just to multiply 120 by root 2 and then divide it by pi, you will be coming up with a 54.01 voltage. Yes, Gauri Muthu Divya, very good. Yes, your answers are correct. It is 54.01 voltage. That's all. I know where you guys had stuck, sir, whether we need to calculate V0 RMS or fundamental. And understand one more thing. Suppose in the same question, I am just asking output RMS voltage. Anyone? What is the output RMS voltage? R stands for RMS voltage. What is the output RMS voltage? Anyone? Just tell me the answer. You guys are writing this formula. Sir, V0 RMS equal to supply voltage Vs into 2D by pi, sir. Really? Are you guys are writing this? This formula is for whom? Pulse width modulation technique. In pulse width modulation technique, basically what we will be doing is, see, let me tell you, without pulse width modulation, actually how your output waveform will be looking like. If you draw the output waveform in x and y axis, our waveform will be like this, a pure rectangular. Up to 180 degree you will have positive, after 180 degree you will have again 180 degree negative, again 180 degree positive, again 180 degree negative. It will be keep on going. When the moment we are applying pulse width modulation technique, see here without pulse width, you can observe we will be having only one pulse. We will be having only one pulse. Here the pulse width 2D equal to pi only 180 degree. In case without pulse width modulation technique, if you consider only one pulse will exist in the first positive half cycle, that duration will be 180 only. Similarly, if you apply pulse width modulation, we saw in our previous questions when we are applying pulse width modulation technique, they told in one case they will be having single pulse, in one case they will be having 3 pulses, one case they will be having 5 pulses, 4 pulses. There are so many things. So they are reducing the pulse width and they are increasing the number of pulses in order to eliminate the harmonics. So displacement angle they are introducing inside the system, and they are trying to adjust the displacement angle such that the lower order harmonics effect will get eliminated and we will be trying to achieve the pure sinusoidal waveform, because we are not, this is not our desired waveform. We are willing to retrieve sinusoidal waveform from this rectangular. For that we are doing some filtering action. That filtering action will be done. It can be done with the help of pulse width modulation technique. So without pulse width modulation technique, 2D equal to pi only. See, if I will substitute this 2D equal to pi, then what will happen? Pi by pi will get cancelled. Root of 1 will become 1. So it clearly stands that the value of output RMS voltage B naught will be equal to supply voltage. Yes, we are correct. Output RMS voltage is simply equal to supply voltage when we are not applying pulse width modulation technique. This 2D by pi will come. It will be visible only when we are applying pulse width modulation technique. Understand? Very good. So now it's time to explore the value of THD, total harmonic distortion. Let us explore that value. We know what is the actual formula. THD can be written as, let me write down, under root of, yes sir, anyone, what is the formula? This can be written as total output RMS voltage minus fundamental RMS voltage square times of total output RMS voltage. This is total output RMS voltage minus fundamental voltage square times of fundamental voltage divided by fundamental square times of fundamental voltage. I hope I am correct. Now we can substitute all the values. What you guys got here? 54.01. Actual output voltage is V0 RMS equal to supply voltage. Supply voltage is 60, so this will be equal to 60. Let us substitute all the value here. It will become 60 square minus 54.01 whole square divided by 54.01 whole square. Keep all the terms under root. Actually, all the terms under root. So what we have to do? 60 square minus 54.01 square divided by 54.01 square. Then we should take, how many of you got the answer? So it will be equal to 48 point, yes. So let me check it one more time. 60 square, minus 54.01 square, we will be getting some answer divided by 54.01 square. We should take root 48 point, exactly it will become 48.38 percentage. Okay, that is the value of total harmonic distortion. So this is going to be THD. Okay sir, fine. I hope we all got the answer. So this is how we have to solve the question. Be clear. See, I'm repeating every time I'm telling that gate question, it may be a bar question. People are telling that bar interview is very tough. This is the world on the top 10 toughest interview bar sir, top 10 adu sir abing. I literally understand why we are thinking like that. Even I too appeared many times for interviews. Listen, let me tell you one logic. Basically, when we are facing the interviews, questions will be asked from the fundamental data. It may be your exam or it may be your interview. It doesn't matter where you are going. They won't ask any question beyond your knowledge, because you people are graduating from BE. The questions also will be came from that BE only. Whatever the things that we are learning here, same will be asked in the examination. But you should be very crystal clear with the concept. Different, you should know how to discriminate it. Fundamental means what? Output RMS means what? THD means what? How to discriminate PWM technique. With the PWM, how to solve the question. Without PWM, how to solve the question. So this kind of little bit clarification is sufficient. You don't need to study this much. Sir, room affiliates, sir. I done those so many things. I did the research. I have studied thousands of books. What is the use of it? You'll be forget everything after 1 month if you leave a gap. So it is useless. It's very important to understand the subject. Once you understand, there is no point of memorizing anything. கடைசியாக என்ன ஆகுனா உங்க மைண்ட்ல எதுவுமே இல்லாத மாதிரி இருக்கும். பட் யாராச்சும் ஒருத்தர் கொஸ்டின் கேட்டாங்கன்னா டக்குன்னு ஆன்சர் வந்துடும். பிகாஸ் எவ்ரி திங் யூ அண்டர்ஸ்டாண்ட். தட் இஸ் தி ப்ராக்டிகாலிட்டி ஆஃப் அவர் மைண்ட் மென்டாலிட்டி. So this should come when you are solving the problem. Be conscious. ஒரு டைம் கத்துக்கிட்டோமா, ஓகே ஃபண்டமெண்டல்னா இதுதான், ஃபண்டமெண்டல்னாலே இப்படிதான் எழுதணும், V01 ஃபைன். அப்ப தேர்ட் ஹார்மோனிக்னா எப்படி எழுதுறது, ஃபிஃப்த் ஹார்மோனிக்னா என்ன, how, why we are keeping our attention with the lower order harmonics, what is the purpose of this pulse width modulation technique. This small fundamental basic questions crystal clear on our mindset la answer rakkanum. That's very important. Fine, so it's not for these things. Let's go ahead with the next question. It's a kind of theoretical question I saw. 1 minute, let me drop that one also. Actually the question is, when we are considering pulse width modulation control technique, a single phase full bridge inverter, we have, let me bring it here. Let us take a single phase full bridge inverter. Let me bring it here. A single phase full bridge inverter. It can operate in, they told that it is being operated. It's being operated in load commutation mode. Load commutation mode. அப்ப நமக்கு என்ன தெரிஞ்சிருக்கணும், லோட் கம்யூட்டேஷன் டெக்னிக்கை பத்தி கொஞ்சம் பேசிக் ஐடியா இருக்கணும். Commutation techniques we might be இதெல்லாம் ஃபுல்லா பார்த்திருப்பீங்க இல்லையா, different classifications of commutations and what we need to remember, everything we have recaptured. I hope you remember. So this is load commutation. So what they are telling is a single phase full bridge inverter, it's being operated in load commutation mode. Now the question is, the load is consist of, if load is consist of. So now they have given four options. என்ன சொல்லிருக்காங்க அப்படின்னா, சிங்கிள் ஃபேஸ் ஃபுல் பிரிட்ஜ் கன்வெர்ட்டர் வந்து லோட் கம்யூட்டேஷன் மோட்ல வந்து ஆப்ரேட் ஆகணும் அப்படின்னா நேச்சர் ஆஃப் தி லோட் வந்து எப்படி இருக்கணும் அப்படின்னு கேக்குறாங்க. So they have given four options for that. But with respect to load, these things are varying, we know, right? So let me tell you, they told, first what they told is capacitive reactance must be equal to inductive reactance. First option they are telling. Second option, they are reversing this. No sir, inductive reactance will become equal to capacitive reactance. So here what is the conclusion is basically XC equal to XL or XL equal to XC, both are not same. There will be a difference between these two people. Let me tell you, don't worry. Option C, what they are telling is, no sir, capacitive reactance must be greater than inductive reactance. No, it is also wrong sir. Inductive reactance must be greater than capacitive reactance. What can be the expected correct answer in this question? See, so basically what is the difference between these two? First of all, understand this. XC will become equal to XL. So what they are trying to mean here is, இப்போ நம்ம இந்த maximum power transfer theorem வந்து படிச்சிருப்போம் in circuit theory. அப்ப என்ன பண்ணுவாங்க அப்படின்னா, when the load resistance value will become equal to the value of Thevenin resistance, then output power will become achieving its maximum expected output அப்படின்னு சொல்லுவாங்க. This condition could be possible only when the value of RL will become equal to the value of RTH. Sir, இதை நான் இந்த மாதிரி எழுதலாமா? RTH will become equal to the value of RL எழுதலாமா? I would have told these things. We should not write like this. This is wrong. Why sir? What is the difference between the first one and the second one? Understand the difference. Basically what it is trying to mean here is, RL will become equal to RTH means the value of RL is variable. We are keep on varying the value of RL, whereas RTH is fixed. This value is fixed. So they are trying to continuously change the value of RL. When this RL will become equal to RTH, it is fixed. RHH is fixed here. Right hand side is fixed. LHS, left hand side, we are varying. When the LHS will become equal to RHS, we are trying to achieve the maximum power. Now come to the second case. If you observe the second case, what I have written, RTH equal to RL, it means RHH is fixed. I told RHS fixed. So they are varying the value of RTH. Is it correct? When we are discussing about maximum power transfer theorem, did I told you like that? Are we varying the law of RTH? No. Thevenin resistance means that is always constant. It is not variable. Only load is variable. So it means RH is fixed, LHS is variable means how can you vary the value of Thevenin resistance? This is wrong statement. We should not write like that. That's why always it should be written like this. Like that they are trying to mean here. Here XC is variable, here XL is variable. Somehow they are trying to match it to equal. Or no sir, XC, when XC will become greater than XL, then it will be possible. No, XL will become greater than XC, then it will be possible, sir. These type of options were given. Now you can consider your answer. What can be the expected answer? Anyone? I don't know how many of you remember these things. Anyway, let me recapture it. Load commutation could be possible only at a leading perfector. That's all. That is the answer. Now you know your fundamental basics that we learn from the network theory will help you to get it. When we will be achieving leading power factor? Leading power factor could be possible by the capacitive reactance. Lagging power factor could be possible by inductive reactance. That's all. Your answer is over. So if you want to achieve the leading power factor, then what will happen? See, when I am designing the circuit with the help of both XL and XC, if you want to know, if you want to achieve the leading power factor, what we must do? We have to increase the value of capacitive reactance. When capacitive reactance dominates the inductive reactance, then the circuit will be behaving as a capacitive circuit such that you will be achieving leading power factor. You can achieve leading power factor. That's all. Suppose if you are trying to, yes sir, I'm doing this. Suppose if the value of inductive reactance is dominating the value of capacitive reactance, then it will goes to lagging power factor. It is not possible to achieve the load commutation. So load commutation could be possible at a leading power factor. Power factor can be brought. We can bring this condition. Leading power factor could be possible only when capacitive reactance dominate the inductive reactance. So the correct expected answer for this question is option C only. Remaining things we cannot consider here. Okay, I hope you all understood this. Fine, sir. Now, what we'll be doing is I'm bringing some homework questions here. You have to try to bring the answer by yourself. Don't ask anyone. Okay, fine, sir. The question is 1 minute. Yes, a single phase full bridge inverter. Write down here. Single phase full. The question is a single phase full bridge inverter is supply voltage. Single phase full bridge inverter is having supply voltage. Vs is given as 200. We know input is DC, right? And they told that it is supplying the load of RLC. Load is given as RLC, and the value of R equal to 2 ohm, and the value of inductive reactance is equal to 3 ohm, and the value of capacitive reactance it is equal to 2 ohm. Now what they given is the output voltage is controlled by pulse width modulation technique. Output voltage controlled V0 means output voltage controlled by PWM, pulse width modulation technique. Whereas they told that pulse width is given as 120 degree. Now what is the question is the RMS value of the fundamental and the third harmonic component of currents are dash. The RMS value of fundamental, just mark the question. I will test your knowledge. Don't worry, definitely I will give the answer. It is my responsibility. But if you are very smart, then what knowledge that I had given already, that is sufficient. Even in the lecture also I clearly taught you how to obtain these things. If you are in the subject clearly, definitely you can bring the answer for this question. The question is the RMS value of the fundamental and third harmonic component. Fundamental and third harmonic current or dash. Third harmonic current or dash. That's all. This is the question. Okay, so just be patient while solving the problems, because this subject is very easy subject. You might have gone through this. So far we have been solved plenty of questions, but you just recapture நீங்க அப்படியே நோட்ஸ் ஒரு டைம் ரிவைஸ் பண்ணி பாருங்க. I have never used any kind of typical formulas. This is this nothing is there. ஈவன் நீங்க படிச்சதுல ஒரு 10% கூட நம்ம வந்து ப்ராப்ளம் சால்வ் பண்றதுக்கு கரெக்டா ரிவைஸ் பண்ணிருக்க மாட்டோம். Nothing is there. Same scenario will be happening in all other subjects also. நீங்க ரிப்பீட்டடா ப்ராப்ளம் சால்வ் பண்ண என்ன ஆகும் அப்படின்னா, ஒரு டைமுக்கு அப்புறம் நம்ம படிச்ச ஃபார்முலாவில இருந்து மட்டும்தான் கொஸ்டின்ஸ் வரும், வேற எதுவுமே வராது. So try to solve as many questions as possible. And I also told you, ஒரு கொஸ்டின் பேங்க் எடுத்தீங்கன்னா அதை ஒரே டைம் மட்டும் சால்வ் பண்ணி தூக்கி போட்டுறாதீங்க. Solve the same question bank 4 to 5 times. Nothing is wrong. ஆனா என்ன பண்ணக்கூடாது, ஆன்சரை பார்த்து இதான் நான் ஏற்கனவே படிச்சிட்டேன் சார், அது எனக்கு தெரியும், ஆப்ஷன் ஏ. I know everyone will remember the options when we are solving ஒரு டைம் 2 டைம் சால்வ் பண்ணதுக்கு அப்புறம் அந்த கொஸ்டின்ஸோட ஆன்சர்ஸ் definitely it will be stored in your mind. Literally we know. That is not a problem here. Again you should solve step by step. You have to approach and bring the same answer. Then feel happy. Yes, I brought the same answer. That things are required. Okay. So solving same questions again and again will help you to build your concept in a proper way. என்னென்ன ஃபார்முலாலாம் எக்ஸாம்ல கேட்குறாங்களோ அந்த திங்ஸ் வந்து அடிக்கடி நீங்க திரும்ப 3 times 4 times சால்வ் பண்ணும்போது permanently it will be registered in your mind, such that after solving a question bank 4 or 5 times, if you are involving with some new questions, automatically that effort that you have put in the previous question banks will help you to solve the new question. That's how people are getting more score. They are not solving lakhs and lakhs of questions. They are solving same questions repeatedly in order to build their concept in a proper way. So what you can do is, if you are solving 8 question, try to solve that question bank 3 or 4 times. Then again by some IES question, do the same thing. That's how you will be getting more knowledge. It will be helpful for you to get very good score in your examination. Okay. So this is all for this lecture. I hope you all understood whatever that we taught today lecture. Remaining things we will see in the next class. Before coming to the next class, try to recapture all your formulas that we taught in the previous